Next up for our parametric equations is going to be the area contained between curves. Now, before we get to area between curves, though, we should probably just talk about finding the area underneath a curve. So when we started this thing back in Calc 1, we simply had y as a function of x, and we said we're going to go in between two x values. We'll call them x equals a and x equals b. And then we did this whole thing where we said let's chop up the interval into a bunch of little tiny subintervals, and then we'll find an area by approximating a Riemann sum. And then the fundamental theorem of calculus came along and said, nope, we're just going to do this. And this will just be so much easier. It'll be great. You find an antiderivative, you plug in your bounds, you subtract the result. Life was good. So how does this translate when we talk about, say, x and y both being functions of t? So x is a function of t and y is a function of t. So first thing we're going to need to do is associate a couple of t values with these. We'll say t equals t1 for the lower one, and t equals t2 for the upper one. So what we're going to do is just take everything that's in this expression and translate it so that it's in terms of t. Now first off, the substitutions that we're going to be making is that x is essentially going to be x of t. As a result, dx, and this is going to look a whole lot like a u substitution, this will be x prime of t dt. That way we can turn our dx into x prime of t dt. F of x is simply referring to the y value, so the y can just stay as y. We'll take whatever the function of y is as a function of t and multiply by x prime of t dt. Our two bounds will then have to be values of t as well. So that'll go from left bound t1 to right bound t2. The super duper important thing here is that your lower bound is on the left and your upper bound is on the right. T1 is on the left, T2 is on the right, and that's going to be very important in the next video. Now similarly, if we were dealing with a function of y, a function of y, sorry, words are hard and I don't talk to a lot of people, going from c to d, like so. If we wanted to find area under a curve like this, we'll say here is x equals g of y. Normally what we would do is we would start by breaking up our interval into a bunch of little tiny subintervals and approximate with rectangles and blah and blah and blah. Nope! Fundamental theorem of calculus once again. This will be the definite integral from c to d of g of y dy. I'm interested in doing the exact same thing as what we did before and just take all of this stuff in parametrics and convert it into t. So y being y of t means that if I wanted to figure out what dy is equal to, that's just going to be y prime of t times dt. So dy will become y prime of t times dt. Now g of y, that's simply referring to your x value. So your x value would just be x of t. And once again, we'll associate t equals t1 with the lower bound and t equals t2 with the upper bound. That way our bounds will simply go from t1 to t2 and we'll be all set. Now to actually use this, well, let's take a look at that in our next video.